name is Michael Ficarra. I'll be talking to you about a project I'm working on called CoffeeScript 2, The Wrath of Conf. You may know me on GitHub like this, or depending on the week, like this. But if you do know me, it's probably from the CoffeeScript project. I do a lot of work on it. I'm this guy right here. Can you see those images? They look really bad now. Whatever. I was funded to work on this project through Kickstarter. I'm working at Groupon right now on the project. They let me use their resources and their employees. I guess you could call those resources as well. This is really bad looking.
You can also turn your screen resolution down a little bit, and it'll look better.
If I turn it down.
No, the 19th, but
That's the, okay, fine. So I have this workflow for the compiler I'm working on. Oh, I didn't poll you. Does anybody use CoffeeScript? Anybody know of CoffeeScript? Cool, CoffeeScript users, great. So you must know the compiler currently and its failings. But I'm redesigning it, and a main goal is to have a lot of useful intermediate representations. And I'm going to walk you through this compilation process that I've designed here. The first step, can anybody read that? Is that better? Okay. So the compiler obviously takes CoffeeScript input, but we need a preprocessor here to take the context-sensitive CoffeeScript and turn it into a context-free language. Once that's preprocessed, so that is obviously useful because we can use different kinds of parsers on that input. I made a peg and generates a CoffeeScript AST. So this process is already done, and the tool is already parsing its own source files. So that's a little look into where we are right now. This CoffeeScript AST can be run through an optimizer then and turned into a subset of those AST nodes that just represent the semantic parts of the language. Now this resultant AST is useful for a lot of different tools. One of the things we can do with it is just run it through something I've been working on called Codegen that just takes a CoffeeScript AST and outputs CoffeeScript code. So it's pretty much just a really fancy way to cat a file. But the interesting way that most people will be using it is trying to compile it to JavaScript and create JavaScript output. So we'll have this compiler that will allow user-supplied rules to augment the compilations, generate a JavaScript AST, and run it through ESCodegen, again with a grammar so to format it however you like.
Can you talk about the user-supplied rules? Like, what's cool about that?
So an example of user-supplied rule. Let's say you want to. Let's say you have you want to conditionally compile some things out. You want to say like, if big debug constant have these logging statements, otherwise do what the app is supposed to do. You can compile, you can define a rule for the compiler that says, if I see something shaped like that, forget about it and just use the other conditional body. Just one small example of what you'd be able to do with augmenting the compiler with additional rules. But where I was the question was, how are user-supplied rules useful? So we'll have this. So there's already a project actually called ESCodegen that will generate. I'll skip over this step, but it'll just generate JavaScript output for us from a JavaScript AST. So I wanted to show you some examples of it working right now. Just some cool stuff we can do with it. So I made pictures, but I want to show you a live demo because I am ballsy, apparently. Here's like a little bit of CoffeeScript that should work. Okay, cool. And we're generating, so this is a representation of the AST. The AST nodes know how to output themselves as JSON. So it's just a JSON representation of the AST that was generated. You can see we have a program that contains a sequence. First operand is a function application of console.log, so member access on console of the log member. Then we have the plus operation between A and B, and a do operator, function literal, no argument or no parameters, and we have a return with implicit undefined. So that's just a basic compilation. I mean, yes. But now we have the compiler will have some advantages over the current compiler. We'll have a standardized intermediate representation. One of them being JavaScript AST. We're using the Mozilla Parser API. This is what Esprima uses that's on. Esprima uses if you have ever used that, or this is the kind of input Codegen uses. So having these standard intermediate representations makes the tool much more useful because there are other tools built around that type of data. The parser will be more powerful and already actually is. So I want to show you, without giving anything away, some examples of things you can do already that you can't do with the current compiler. So simple things, which we've had a branch around for a long time now that called listed functions that has never really been up to par, so it's never been merged in. But my parser has no problem handling those. And it can handle things that are a good deal more complicated than that. Can just do something like, and then like, oops. So you can see I have these more complex functions here being passed as arguments to a function application here, with no problem parsing it. I also can do nested talking and coding at the same time. It's too hard for me. Nested string interpolation. So I'll give you an example. Something like, I'm just checking everything's right. Something like that. You can see here it's represented as concatenation operations, but that's because interpolation is the only way to actually explicitly concatenate strings in CoffeeScript. The plus operator may mean certain things in certain contexts, depending on the type of the data it's being used on. And I hope I have enough time to get through some. So this is going to be pretty cool. We have the error reporting is not so great with the current compiler. You'll get errors like, you have an unclosed curly brace even though you don't have any curly braces in your file because the rewriter has added curly braces for you. Problems like that. And the error reporting here is pretty cool. Let's say you wrote something like just a function. Let's say you had a tilde there where the dash should be because you can't tell the difference with your font. It's going to tell you what line, what it saw. It's going to show you the line. It's going to point right to the character that caused the problem, or in this case, the character here is because it's thinking it's a binary, a bitwise not operator. But anyway, we'll have really cool errors. I mean, you can also say you forgot, you have like you have a closing parenthesis there. Oh, that's still wrong, obviously. I'm just going to show you where the wrong parenthesis is. Oh yeah, so there's other advantages. We're going to, the parser forces consistent indentation. Make sure if you've ever gotten a problem where it thinks you've dedented and you haven't because the indentation is inconsistent, that's already fixed. Using two-pass variable naming so that your variable names that you're using are not conflicting with the ones that are being generated by the compiler. You can specify the output formatting, as I showed you earlier, and there will be line mapping so that your debugging is a lot nicer. When you have JavaScript errors being thrown, it'll just actually tell you what line in CoffeeScript the error happened on. So I'm gonna, now there's also a lot of tooling advantages. The compiler is really useful for making automatic code formatter for your editor. So you just hit one button and your code is formatted exactly how you specified in some grammar. Syntax highlighters would be benefited by this, code coverage tools, and you can do a bunch of static analysis on these ASTs that are being generated because we have these really useful intermediate representations. That's what I want to get across today. Here is an example of some of the tests in CS Codegen, just to show you how we're using it. So can you read that at all? For example, we have here, there's a test, unary plus operator on 0 with a unary plus operator around it. It needs to make sure it's parenthesized, otherwise it'll look like you're trying to increment it with a plus plus operator. Things like that, it has to understand that and has to generate good CoffeeScript code. So this is like what ES Codegen will be doing for the JavaScript code that's output. And this is also where I will be testing all of the formatting grammar the effects of the formatting grammars that I'm going to be accepting with CS Codegen or with ES Codegen. Now for something, do I have time for Keith? Yeah? Okay, cool. So I was just going to show you some cool CoffeeScript features that not many people know about unless you really follow issues or anything like that. Here we have let expression. So this is a common pattern writing, making a function that's passed an argument to rename this. So say this name is whatever expression is down here in this context. And we have this syntax for it here, the do syntax applied straight to a function with the default argument. We have these not in, not of, not instance of operators that don't seem to be used very often. They're just the negated form of in, of, and instance of. So that's pretty cool. Classes can be anonymous. You don't need to name your classes. They don't need to be declarative. They don't need to be statements either. They can just be expressions. So you can just pass it to a function as an argument or use it any way you want. They can be anonymous. This is pretty cool. You can switch without a condition. Switches on truthiness. So if you want to, I guess it's useful for trying to do, it's pretty much like an if-else if with a bunch of, the useful part is when you have many conditions in the when, you get to duplicate the block of code that's executed. You can destructure anywhere an assignment's happening, whether implicit or explicit. So here, when your key is being named, or here, and since it's a foreign, your variable name can be a destructuring assignment, even though it's not, there's no equals operator. It's still an implicit assignment. And here, another implicit assignment is happening with arguments. Function arguments can be destructured. Some people, surprisingly, don't know this. The semicolon is just the seek operator. So use that if you feel it's useful. And we just recently introduced binary number literals. So if you have binary data that you're putting straight in to your CoffeeScript code, use a binary number literal to represent it in the way you want. You can follow a project on Twitter, cs@groupon, spelled like that. And of course, follow the project on GitHub. Questions? Purple?
I have one question. So with CS Codegen, so if you feed CoffeeScript source to your Ficarra and then feed the AST out to CS Codegen, and then CS Codegen generates CoffeeScript source, will it be byte for byte exactly the same? Like you said, it's
Not necessarily, because you can, let's say you just add a bunch of white space that's ignored by, but it's not represented in the AST. Technically it's represented, but it's not significant. It's just stored for historical purposes.
So in theory you could write it like a cat.
You could, yes, you could, by saying, oh, how was this originally represented? I'm just going to represent it in that way. But what it's doing right now is saying, what is the structure of this? I'm going to represent it in the way that I think is best. It will be able to take a grammar that says, in what way was I told to represent things that look like this? More questions?
So you can customize the area, let's say created AST, and the default implementation of Codegen for that AST is one way. I want to override it. Can you do that?
So the question is, could you overwrite the default for the default rules for generating the code? And yes, that's the whole point of it, is that there will be these same defaults, but you can have it format any way you want. Another question?
I remember there was an issue about adding tame.js to CoffeeScript, and it was ultimately shut down because it was impossible or something to turn. Or is that now possible?
Well, it wasn't impossible. It was just one of the goals of the compiler is to have a very readable output. And what tame.js was doing was it was using continuation passing style. It captured the rest of the file as a continuation and made a mess of it either way, no matter what strategy you would use. There are alternative syntaxes that are being considered, but that's not really a failing of the compiler. It's a failing of the developers to come to a consensus. Any more questions? Okay.